Hey everyone, in this video we're going to learn a little bit about equilateral triangles and then a lot about isosceles triangles. So I'm where I left off, except I added this little measurement down here. So the first kind of triangle we're going to talk about is equilateral. If I pull this point E up to the top here at C where those two circles intersected, it's a little bit high, there we go. We can see that we have created an equilateral triangle. All sides are equal. Equilateral. Lateral means side. So we have 5.7, 5.7, 5.7. That's how you construct an equilateral triangle. You draw the circles to either side, run a line through, and put your sides of the triangle up to where the two circles intersect. Now, if I move this point E off of that point C, I have created an isosceles triangle, meaning two sides are congruent. As you can see here, we have our two sides congruent, 4.4, 4.4, no matter where I drag it. So I'm going to leave it right here because it's 5s, which is nice. I'm going to mark these so that I can show that they're congruent. Style, decoration, boom, boom. Okay, now I'm showing that they're congruent. So we have an isosceles triangle, two sides are congruent. Another conclusion that we can get is that both of the base angles are congruent. In triangles, angles are in proportion to the sides. Sides are in proportion to the angles. So the larger a side is in relation to the rest of the triangle, the larger its opposite angle is going to be. So for example, here we have that these two sides are equal. Therefore, the two angles opposite are congruent. Here, let's see. So the way you tell it's opposite, you got your angle and it points right at where it's going. This one points right at its opposite side. Move this over so you can see it a little bit better. Okay, so if we have an isosceles triangle, then we have two congruent sides and two congruent angles at the base. Now, let's take a look at what that would look like in action. Here's all of our conclusions. If we have an isosceles triangle, two congruent sides, two congruent bases. If we have two congruent sides and two congruent bases, it's an isosceles triangle. So, in isosceles triangle JKL, alright, let me go over here. An isosceles triangle JKL, it's telling us it's isosceles. It's also then saying JK is congruent to LK. JK is congruent to LK. Okay? Those are the two sides that are congruent for our isosceles triangle. And the measure of angle K is 80 degrees. So we're going to write down that this is 80 degrees. We need to find the measure of angle J and the measure of angle L. Well, we know that since these two sides are congruent and that it's an isosceles triangle, this has to be congruent to this. Alrighty, so, long day. All three angles of a triangle add up to 180. That sounds a lot better. Okay. So all three angles add up to 180, and we know that this one is 80. So if we take this one out, if we subtract this, then we'll be left with the sum of these two angles. So 180 minus 80 leaves us with 100. This 100 is both of these angles combined. So how do we find out how much each one is? Well, they're both congruent, so we can just divide this by 2. Let me start a new line here. 100 divided by 2 equals 50. So this is 50, and this is 50. 50 plus 50 plus 80 is 180. Happy triangle. So that is how you apply your knowledge of an isosceles triangle to find missing angle measures.